The first time I tried VR, I was blown away. I would not have been able to tell beforehand what the experience was going to be like. Having a virtual world placed over your head so it's the only thing that you can see, and when you turn your head and look around, it's still the only thing there. And then you can pick things up and interact with them in the world. It's surreal, and when I was finished, I could not wait to see what was in store with the future of VR. So I was browsing and looking up tech news and stuff like that, and I noticed that there were a lot of people coming out with their own VR headsets. This got me excited. I wanted to know, what are they doing with these? What new features have they come out with? But then I was disappointed because all these new headsets by all these huge names, they were just doing the same things. They were repackaging the Vive or the Rift and slapping their name on it with maybe a few interesting features that really didn't add anything to the actual VR experience. It seems like VR is gaining traction and picking up steam, but nobody's actually doing anything with it. They're just saying, hey, this is a market that we can make money off of, so let's do what they're doing. But they're not saying, hey, this is a market that we can improve on. This market has potential, this platform has potential. We can bring a better experience to the people, to the consumers. We can actually go for it and make something revolutionary and really bring the best out of this industry. I'm not hearing that from any of these companies, any of the big names that really could bring VR to the masses. If the problem is money and consensus from whatever board is in charge of these decisions, then they need to sort that out. But if it's not, if maybe they need help or ideas, that's what this video is about. So let's start with what we're trying to do with the headset. All the technology in the world would not help any endeavor unless you understand the purpose. And for a headset, the purpose is to trick the senses, to make the brain believe what is essentially a lie, that is the world that we want to play in. So there's a lot of room for improvement in display technology in both the Vive and the Rift. They're pretty much the same displays as far as specs. They might even be the same manufacturer. Now, our field of view is everything that we can see without moving our eyes or our head. So right about there, that's my field of view. Now, if that view is restricted too much, like this, it can feel like wearing horse blinders or a diving mask. It's not comfortable. That doesn't kill the experience. Plenty of people are enjoying the Vive and the Rift or whatever other brand headset they're using, but it would be that much more immersive if we were to have a field of view that was much more similar to what we experience in the day-to-day. Taking it from the spec sheet, the Vive and the Rift both have a field of view of 110 degrees, but our field of view is double that angle at 220. That's what this is right here, a 220 degree angle across the vision. Now, we also have a vertical field of view, which is 120 degrees this way. Same deal, eyes not moving, top to bottom. And it's 120 degrees with a 10 degree downward tilt, which means that if you're taking level sight as 0, it's 50 degrees up and 70 degrees down. One thing to note is that vertical field of view is not listed at all on the Vive or the Rift or any other head-mounted display that I can find. Right now, it's pretty much just a tiny screen on the display in front of each eye. But if we want them to encompass our entire field of view, they need to wrap around each eye. You could do this with a tiny multi-monitor setup like NVIDIA Surround, I think is what it's called. But even better would be flexible OLED panels like what I believe Samsung and LG are both working on that technology. Another thing is resolution. I think both headsets would definitely benefit from an upgrade in this case. Low resolution can give you blockiness, rough edges, and a general lack of detail, which is a clear indicator that you're in a game, and the whole idea is to not remind you that you're in a game and to convince you that what you're seeing in the world is real, so that you can more easily get into flow and immerse yourself in the game. In a previous video, I made the incorrect assumption that the point at which you can no longer see pixels is the same point at which you will no longer benefit from more pixels. I was wrong. According to Palmer Luckey from Oculus, you do see benefits past that point, and he gives several examples to prove that, like fine, like individual hairs and things like that, really fine details. To save you time, I found a better answer. A Finnish company named Varjo is working on a HMD, head-mounted device, codenamed the 2020, with 70 megapixels per eye. It's designed around providing the maximum resolution for the human eye. Now, I can't find anything that validates the specific 70 megapixel number, but Varjo's team is full of experts in the field, so I think in this case we can just take their word on that. Now, 70 megapixels per eye is, I think it's 50, I did the math, it's like 55 times the resolution of the Vive or the Rift. So to push those pixels, you're going to need some serious hardware optimization, and that's what Varjo has done. They've incorporated eye tracking technology so that the system knows where your eye is looking, and it can provide higher resolution in the center of your eye where it's most important, and lower resolution towards the edges where you wouldn't be able to see the difference. So it's probably still going to be much more hardware intensive than current headsets, but much less than it would be if it didn't have this eye tracking technology and conserve resources for the higher pixel count that it's going to provide in the more detail-oriented parts of your vision. And now we come to frame rate. VR's current 90 FPS minimum is pretty high by most standards, but the fact that we have monitors with 200 plus refresh rates is a testament to the fact that we can see more than that, and higher frame rate would benefit us. In an article I found on PCGamer.com, assistant professor to some school somewhere, I'll put it on the screen, Jordan DeLong says that at about 200 FPS is the point where it becomes indistinguishable from real life. But he also says previously that you can see artifacting at 500 FPS, so we could go with 200. But the little note about the 500 FPS artifacting makes me a little bit more curious. So let's look at what's out there. The fastest refresh rate that I found in a monitor is at 240 hertz from a BenQ Zowie. I forget the rest of the model number, but there you go. And that's wicked fast. We could just throw that in there and be done. But I stumbled upon something from NVIDIA. At GTC 2016, they showcased a panel that they designed specifically for VR that refreshed at 1700 times per second. I will not say another word. So now we have a headset that encompasses our entire field of view, has resolution high enough to the point where it would be indistinguishable from real life, hardware optimization that maximizes performance within this incredibly hardware-intensive resolution, and a frame rate that could not be blamed for causing lack of immersion. But the fact remains that the headset is still attached to the PC by a bundle of wires. It's not a big deal, and anyone who plays regularly has gotten used to it or gone out and spent $1 billion on a VR backpack. But what if you didn't have to do that? What if you could just say, hey, what are wires? Intel's WiGig module, built with DisplayLink wireless connection for VR headsets, that's what it's designed for. It uses the 60 gigahertz band, which provides increased bandwidth but decreased range, and it's very susceptible to interference. But under optimal conditions, it provides all of that with quoted at 7 milliseconds of latency. When compared to a VR backpack, the WiGig module is a lot lighter and requires much less power because the PC is sitting on the table still and connected to the wall. So all that has to power, the only thing you need a battery for, is to power the headset and the earbuds. So, I mean, that seems really good. Let's throw that in there and be done with it. Now, both the Vive and the Rift require you to set up some sort of sensors for tracking the headset and your controllers. But who needs lighthouses when the headset tracks itself? Inside-out tracking is in the works by several companies. It's by no means perfect and does increase latency compared to regular outside-in tracking with the sensors, but that can be improved with future revisions, and it's a small price to pay for the increased freedom. We depend on our ears a lot more than we often give them credit, and it's imperative that, especially on a platform as immersive as VR, that we have audio that is clear and sources that are unmistakable in the 3D environment. Now, thankfully, there's no lack of research into audio playback technology, but as far as hardware is concerned, there's not that much that we can do, because for the most part, 3D audio is all software based. Now, the technology exists, it's been around for a long time. It's just up to the developers to actually implement it into their game or simulation. All we can do on the hardware side is make sure that we include a half-decent headset to make sure that the audio quality is not an afterthought. I will emphasize, though, that as VR grows as a platform, 3D audio technology must make similar strides. Things like audio sounds coming from far away or through walls or echo effects need to be improved. Ergonomics. It's not directly tied to immersion, but a headset that's uncomfortable to wear is not one that you're going to be wearing for very long. Now, the first thing we can do to make it more comfortable is to reduce the weight. A lighter headset puts less stress on your head and neck and lets you play for a longer time uninterrupted. A few other things like breathable materials or a flip-up display like Dell's new headset has would also be nice. Everything we've talked about so far has been packed into the headset, and that's all well and good, but what about the controllers? The Vive and Rift controllers and their different variations aren't necessarily bad, but like everything else that we've talked about, could benefit from some cutting-edge technology. When I first thought about giving VR controllers a makeover, my mind went to gloves with full finger tracking. But if we stop there, we're selling ourselves short. If we have gloves, then why don't we try to incorporate some sort of touch sensation and allow us to feel things in the virtual world? There are several ways to do this, and I'm aware of several different products in different stages of prototyping. Some vibrate, some of them push and pull your fingers, some of them directly press on the skin in different ways, but they all provide physical sensory feedback according to the in-game stimulus. Of all that I've seen, I think I like GoTouch's solution the best for its elegance. It presses directly on the finger and can provide varying levels of pressure. And because of its relatively small size, it should integrate into other glove systems better than offerings from people like Dexmo, Exos, and VR Glove. But it doesn't stop there. We can provide kinesthetic resistance feedback to the entire body. The proud few behind products like Tesla Suit, Nullspace VR, and Axon VR have what we're looking for. Axon VR has very impressive goals, but it's incredibly unlikely that they would be able to bring their product to market with any sort of family-friendly price. Nullspace VR and their Hardlight suit, with its adjustability and sweatproofing in mind, is a much more attractive product when you look at simplicity and versatility. These two factors are incredibly important when breaking into an industry, and so I have very high hopes for Nullspace VR. Many of the features that I've listed are limited by bandwidth, battery technology, and graphics horsepower. Others are limited by developers themselves or the R&D necessary for more advanced technologies. VR is an incredible platform, and even what we have right now, though I have bashed it this entire video basically, is incredible and takes immersion to a whole new level. If you haven't already, I encourage you, find a way to try it out yourself. There really are no words to describe the experience. Also, let me know if there's anything I missed or anything that you'd like to add to VR setups as they stand right now. I'd like to revisit this topic in the future as things develop as well. Anyway, that's it for this one. Use the buttons below, and I'll see you in the next one.